Let's solve problem 2815 using an alternate method. In 2815, that the EMF of the battery is 24 volts, at what rate is thermal energy generated in the 5 ohm resistor shown in the circuit? We want to find the rate of thermal energy generated, so we are looking for power. So we want to find the current in that 5 ohm resistor, and one way of finding current is using Kirchhoff's voltage rule. It's a universal way of solving all these circuits. So let's try that on this problem. We have a 24 volt battery, and we want to simplify the circuit just a little bit. We are going to add these two resistors in parallel, and so there's two of them. So our parallel will be product over the sum, 10 times 10 over 10 plus 10, which will give me 100 over 20, which will give me 5 ohms. So now this circuit looks like this. 24 volt battery, 10 ohm resistor here, 5 ohms here, 5 ohms here, and then a 10 ohms on the bottom here. Alright, so we got this circuit. We want to find the current that's going through this 5 ohm resistor here. So let's try it from Kirchhoff's voltage rule. Just try something different. We'll mark our batteries, positive and negative, and let's assume current directions. Let's go, I1 is going around like this, and then we'll have I2 coming down like this, and then I3 coming around like this. So if I look at this junction on top here, I've got I1 going into that junction, I2 and I3 coming out. So immediately I have that I1 is equal to I2 plus I3. Okay, I want to find I3 is what I want to find. So in this case, I'm going to solve the right loop and the outer loop. If I do the outer loop, I would have, let's just start from any point here. I forgot to mark my resistors. So with I1, I have positive, negative on this 10 ohms, and with I2 coming down, I have positive on top, negative on the bottom. I3 coming down, positive on the left, negative on the right, positive on top, negative on the bottom. Wherever my current enters the resistor is the positive end. Wherever it exits the resistor, that's the negative end. Okay, now we have everything marked. Let's do the outer loop. And walking counterclockwise, I'm going to have 10 I1 minus 24 plus 5 I3 plus 5 I3 equals 0. I want to get I1 in terms of I3, so I have 10 I1 is equal to 24 minus 10 I3. Or in other words, I1 is equal to 2.4 minus I3. Okay, that's one equation. Now I want to do the right loop as well. If I do that, I would have negative 10 I2 plus 5 I3 plus 5 I3 equals 0. In other words, 10 I2 equals 10 I3, or I2 is equal to I3. Okay, so since I1 is equal to I2 plus I3, we would have that 2.4 minus I3 is equal to I3 plus I3, because I substituted in for I2 as well. Add the I3 to both sides, so 2.4 is equal to 3I3, or I3 is equal to 2.4 divided by 3, or 0.8 amps. So now we've got the current in that third branch, which is the current through the 5 ohm resistor. The power then in that 5 ohm resistor is I3 squared times the resistance, 0.8 amps squared times 5 ohms, and that is 3.2 watts. So this is an alternate way of solving the same problem, this one using Kirchhoff's voltage rule, and we came up with the same answer, 3.2 watts.